We're now doing questions on area and perimeters. Okay. First one is calculate the area of the shaded region in the diagram. Now, what you got to imagine that you get the area of the full rectangle, and then take away the area of the small triangle, and that will get you the answer. Okay. Now, when you're going to, you'll see a page with all the formulas on it. You're going to use the area of a rectangle is length by breadth or length by width. The area of the triangle is a half base by height. So that's what we're going to be doing here, okay? So the two of them we're going to do is we're going to do length by width, which is 20 times 15. So 20 multiplied by 15 gets you 300. It's 300 meters squared. Remember, area is always meters squared. Then the little the triangle here is it's meant to be 15 from here to here. 7 of it is from here to here. That makes this part 8. It's 20 from here to here, but it's 14 from here to here. That makes that part 6. So that triangle is going to be a half 6 times 8, which is going to be 24. To get the area of the blue area, it's going to be 300 minus 24.
You're not meant to just half the 6.
Which is 276. Now, okay guys, the Department of the Environment designs a flag consisting of a blue triangle, OPQ. That's a white triangle OPQ on a white background. Okay, OCBA. To display on beaches that have very high standard of water purity. The flag OABC is a rectangle with 1 meter. So Gavin, 1 meter we're going to change to centimeters. It's going to be 100 centimeters by 80 centimeters. Okay, you have to have them in the same currency, so to speak, or the same units. Okay, so that's 100 centimeters. P is the midpoint of CB. If P is the midpoint, that makes that 50, and also makes this length here 50. Okay. Then what I also say is Q is the midpoint of AB. That makes this one 40, and the next one here also 40. Calculate the area of the blue sector of the flag. Now, to get the blue sector, okay, I'm thinking is I have 3 triangles. I'm just going to add 3 triangles together. I'm going to call them triangle A, B, and C. I'm just going to add them together. So it's going to be a half 50 times 80, a half base by height, that's A. Triangle B is a half 50 times 40, and that's triangle B. And triangle C is a half 40 times 100. Now what we're going to get here is we're going to get 40 times 50, which is 2,000. Plus 1,000.
Thank you, Arsenal. Would all teachers please keep their absence kept outside the door? Just an announcement in relation to first year will be cancelled for tomorrow. First year will be cancelled for tomorrow. Thank you. Okay, plus 2,000. Okay, so what we get is 2,000 plus 1,000 plus 2,000 gives you 5,000. It's 5,000 meters squared. Right, so just 3 triangles. Nothing you haven't done before. Okay. Sorry, is it centimeters, is it? Yeah, sorry, my bad. Centimeters cubed. Centimeters squared. Excuse me. Okay, guys. Next one is it's the area of find the area of each of these following triangles, insert form, correct to 1 decimal place. Now, there's actually there's 2 different ways of doing this. Okay, so I'm going to show you. Yeah, I'm going to show you the different ways of doing this one, okay? Now, there's a formula that's on the page here, right? You go down to triangle. Now, see this one here? Area is this formula here. S brackets, square root of S multiplied by S minus A, S minus B, S minus C. Just bear that in mind for a second, okay? So, area equals square root of S minus A, S minus B, S minus C, and to get what S is, we got to do S is all the sides added together, divided by, is it divided by 2, is it? Yeah. Okay guys, to get the area, here's what we do.
What's the
S is just S is basically just you add all the lengths together, divide by 2. It doesn't actually really mean anything, but when you put it into the formula, it works for the formula to get you the area. Okay, so I'll give you the first example would be what's it? 5, 7, and 8. 5, 7, and 8 are the 3 lengths. So what I can do with the S formula is add 5 plus 7 plus 8 all over 2, and S will be what number? 12 plus 8. It's 10. 20 divided by 2 is 10, right? No, it's 10. The area, therefore, is going to be the square root of, and you just replace, anywhere you see S, replace with 10. So it's going to be 10 bracket, 10, it doesn't matter which one you make A. A is any side you want it to be. Call A 5. Then the second one is 10 minus 7, and the third one is 10 minus 8. And what this should do is, this should give you the area of the triangle. Okay, so you're best off just to put it straight into the calculator. Okay, so it's going to be the square root of 10 brackets. What's 10 minus 5? 5. 10 minus 7, 3, and 10 minus 8 being 2. And the answer will be 10 root 3. So your answer is 10 root 3. Okay, so it's just a matter of using the formula and put it in twice. Okay, you can do that for the other two, because this one is 8 and this one here is 8, so you can do the same formula for that. And what about the length of this one? 7, 7, 4. Okay, that's handy enough. Alright guys, the next one we have to find is find the area of each of the following trapeziums. Now a trapezium is something, trapeziums are a 4-sided object where 2 of the lines have to be parallel. So you'll see in all of these diagrams, there's always going to be 2 diagrams that are parallel to 2 lines that are parallel to each other. So it's very much a case of just going to the page with all the formulas on it and finding where is the area of the trapezium. Okay, so it's asking for the just asking for the areas. Okay, so it's asking for the areas. So we'll go to the next page and figure out which one we're looking for. Okay, there's the area there. It's A plus B, the length of one side, the length of the other side, over 2 multiplied by H. So A plus B over 2 multiplied by H. Okay guys, so here we go. A plus B over 2 multiplied by H. So let's figure it out here for the first one. So the first one, what Jack said is correct. A should be 5. B should be 7, all over 2, and what's the height? 4. 12 divided by 2 is 6, 6 multiplied by 4 is 24. It says all measurements are in centimetres, 24 centimetres squared. Happy enough with that? Okay. Do we put, no need to put into decimals. There's actually the answer for the first one that I should have, the other one I should have put into decimals was 10 root 3. And then I press that button and it gives me 17.32. For the question those did there's no need for decimals. Sorry? There's a decimal. You have all the numbers though, 9, 4 and 3.6. Just matter of putting into the formula and wherever you get is the answer, okay? The next height. Here we go. Okay. The next one, a rectangular piece of metal has a width of 16 pi centimetres. That's 16 pi from here to here. Okay, 2 circular pieces, each of radius 8, are cut from the rectangular piece as shown. Find the length L of the rectangular piece of metal. Okay, the length is, see the way the radius is 8, and 2 radiuses just about fit in the width. That means the width should be 16. So the length is 16 pi, the width is 16. Calculate at the area of the metal not used. Okay, so the shaded region. And what we're going to do is we're going to get the area of the metal that is used. Okay, so the area of the metal that is used is going to be 16 by 16 pi. Okay, area of the rectangle first. If that's going to be 16 by 16 is, I think it's 256. Yeah, 256 pi. Now, what we got to do next is we got to take away the circles from that. Now, the area of a circle is pi r squared, and it's just a matter of leaving pi where it is and putting in 8 squared. Each circle is 64 pi, so that's 64 pi The other one here is 64 pi. So how much is left over?
Minus 128, so it's...
Yeah. It's 128 pi. Okay. Express the area of the metal not used as a percentage of the total area. What was the total area? The total area was 56. Well, how much metal is left? 128. That's what you said, but 256 minus 128 is 128. And then you multiply by 100 over 1. And what we get there is 50%. Okay guys, just going to set this off in a couple of questions.